A lot of the topics that we look at in college algebra will eventually become individual steps of much larger problems, and our next three examples give us a taste of that. The results that we see here, or the expressions that we see here, are the results of problems that we would work in calculus. We would arrive at these somewhat messy and ugly looking expressions and then try to figure out how to simplify by factoring and combining like terms. While they do start off looking somewhat ugly, it's important to note that what we have in each of these cases are simply two terms. They're rather long terms, but we have a first term and a second term. We can start off by applying that idea of looking for greatest common factors. In this case, both the first term and the second term have a 6 in common, and they also have 7x plus 6 in common with one another. To start then, we'll factor out the 6, and we'll factor out the quantity 7x plus 6, and look at what we have left over. In our first term, we had 7x plus 6 squared. We factored out one of those, leaving us with still one left over, plus what we have left over in the second term, which would be the quantity 6x plus 7 times 7. We can drop those parentheses to rewrite this as 7x plus 6. And then in the second term here, we'll distribute 7 through to get rid of those parentheses, rewriting this as 42x plus 49. This means we can rewrite our final answer as 6 times the quantity 7x plus 6, the two factors we initially pulled out, times the quantity 42 plus 7, which will give us 49x, plus 6 plus 49 will be 55. So look at the two terms, identify any greatest common factors between them, and then we simplify by combining like terms, whatever is left over. In example 15, we don't have a 6 common in both terms, but we do have a 6 and a 4, which will both be divisible by 2. So we'll be able to start off by factoring out a 2. They share x plus 3 in common. And in this case, we can factor out x plus 3 to the 5th. And they have x minus 4 in common, meaning we can factor out x minus 4, in this case to the 3rd power. We factored out a 2, which will leave us with 3 times the quantity x minus 4. And then in the second term, we still have x plus 3 left over. And where we had 4 but factored out a 2, that will leave us with 2 left over. Distributing through will give us 3x minus 12 plus 2x plus 6, or a final factored form of 2 times the quantity x plus 3 to the 5th power times the quantity x minus 4 cubed times the quantity 5x minus 6. Example 16 looks even messier than the previous two that we've considered, but we'll start off with exactly the same approach. We can identify 7s that are common, meaning we can factor out a 7. 2x minus 3 is common, so we can factor out 2x minus 3. They share a 2 in common, so we'll factor out a 2, and then in terms of 7x plus 1, we'll be able to factor out 7x plus 1 to the fourth power. What's left over then will be the quantity 7x plus 1 plus the quantity 2x minus 3 dropping those parentheses and combining like terms will give us 9x minus 2. So we can rewrite our final answer by taking 7 times 2 to get 14 times the quantity 2x minus 3 times the quantity 7x plus 1 to the fourth power times 9x minus 2. Again, for each of these, recognize that all we're dealing with is two terms, and that some of those factors will be in common between them. Once we factor those out, then we deal with just whatever's left over to simplify and combine as much as possible.